Good morning, everyone. Today we'll be discussing about our project Hostel Resident Grievance Management System using blockchain. I'm Harshita Raj and my teammates are Sahasra, Divya, Pratisha and Harshnisri. So basically our project focuses on providing a secure, transparent and efficient complaint redressal system using blockchain technology, especially for hostel students. And now we'll be explaining about the implementation of our project. Divya will be explaining about the implementation.
So now I'll be explaining about the implementation part for our hostel complaint management system. We basically have three roles: student role, lower admin, and then the higher admin. For student, we basically have integrated two authentication paths. The first one is using the Gmail, and the second one is using their Wi-Fi username and password. Uh, for both lower admin and higher admin, we have only integrated the Google Auth API for authentication. So we have to click on this login with Google, and then we have configured which email are lower admin, which email are higher admin, and which emails are student. So now I'm clicking on the Divya Prabhakaran email ID, which is basically the student email ID. So now I have to enter the Wi-Fi username and password. In the dashboard, we'll be able to see all the complaints that has been issued by the particular student. So this one is student specific. So here we can see all the complaints, and the status of the complaint are either pending, in progress or completed. So this status is changed by the lower admin or the higher admin. We have this escalation process of 3 days. So if the complaint has been not resolved by the lower admin within 3 days, then it will be escalated to the higher admin who have to solve it for sure. Uh, and then after the complaint has been resolved, which means its status becomes completed, the student can give feedback. So if they are satisfied, they don't need to give any feedback. But if in case they're not satisfied, then they have to give why they're not satisfied, and they can reappear the complaint for at most 3 times. This is basically our workflow of this hostel management system. Here in the dashboard, we have this dashboard which refers to this page itself, and then add complaint, where we can add the complaint. We have to give the image URL if in case we have this complaint of the tap leakage. We can take a picture of that tap and then convert that into an URL and paste it here. And then in the category, we can choose something. I'm just choosing unclean water, and then we have to give the block name. So I'm giving F, and then floor number, convert that into an URL and paste it here. And then in the category, we can choose something. I'm just choosing unclean water, and then we have to give the block name. So I'm giving F, and then floor number 5, and room number is optional. I'm just leaving it. We have this live preview which shows all the complaint details, and then I'm submitting the complaint. For submitting the complaint, obviously it will ask for MetaMask verification because we're doing some transaction to the contract address. Now if we go inside the dashboard, we can see the complaint that we have arised now. The status is pending, obviously, because we have just arised the complaint now. And then in the announcement module, we can see the announcement made by the admin. So this one does not this one is not related anywhere in the blockchain, but for if in case if the lower admin or the higher only the higher admin can give the complaint, can give the announcement part. So when the higher admin is posting an announcement, the student will be able to view that. The higher admin will also be able to edit or delete the complaint. So here they can view all the announcements. For in case like we have Darbar night today from this time to this time, the student will be able to view that. That is what this announcement module is for. And then we have this connect or disconnect button, which connects to the MetaMask. So this is basically a dashboard. Here we can see that here we have this unsatisfied button. So if you're unsatisfied, we can click on this unsatisfied and then say why we feel that the complaint has been unsatisfied. I'm just giving not properly resolved. Confirming the transaction. So now, since we have reappeared the complaint status starts again from the pending, even though it has been already completed. But Since we are reappearing it, it starts again from the pending file. So this is all about the student dashboard. We have this feature of raising a complaint, giving feedback, and reappearing the complaint, viewing the announcement also. Now for the lower admin, lower admin will be able to see all the complaints that are less than 3 days and not completed. So if they have a complaint which is not completed yet it is more than 3 days, it will not appear here, it will appear in the higher admin dashboard. Here we have all the complaints. The admin have to read all the complaints and resolve it accordingly. For example, in the complaint 2, I'm just making it in progress, which means the lower admin has read this complaint and now he or she have taken some action, but it is yet not completed. So now the complaint has been in progress, which is changed by the lower admin. They can also make the complaint completed by clicking on the completed button. And now the complaint is completed. So any feedback that's been provided by the student will appear here. They also have this connect disconnect button. So this is all the functionalities of the lower admin. And then for higher admin, right now the higher admin dashboard does not show any complaint because all the complaints that's already more than 3 days are resolved, so it's not showing anything. But if in case there's a complaint, then it will display here. In the admin dashboard we also have this extra access of creating a new announcement. So here if we click on this add announcement, we'll be able to add the announcement. I'll be giving an announcement that no Darbar night from 5 p.m. to 7 p.m. on 5th October. Just some random announcement. Another announcement have been added successfully. So we, after adding the announcement, the higher admin can edit the announcement or they can delete the announcement. So this is all the functionalities of lower admin, higher admin, and then the student. The basic workflow of our application is that the student will be able to raise a complaint. The lower admin has to solve it. If they are not able to, then the higher admin have to solve it. And after solving it, the student will give the feedback. Again, if it is not satisfied, then the student can reappear the complaint, but it also has a limit of 3 days. And this is all is done using blockchain. Thank you.
Now I'll explain the smart contract part of my project. This smart contract is written in Solidity and it represents the core backend logic that runs on the Ethereum blockchain. It is responsible for securely recording, updating, and tracking the student complaints in a transparent and tamper proof way. Here I have mentioned the Solidity compiler version and the license identifier. Then I created a contract called the Hostel compliance system, which defines all the rules and functions related to the complaint. Inside the contract, I first define an enum called status, which represent the possible states of the complaint. Pending, complaint is newly resolved. In progress, currently being resolved. Completed, issue has been resolved. Then I defined a stack called complaint, which acts like a blueprint for storing each complaint data. It includes complaint ID, student address, image is optional, and test description of the complaint, block name, floor number, room number, complaint category, status of the complaint, and timestamp to record when it was raised or updated, reopen count, how many times it was being reopened after being unsatisfied, array of feedback. It stores the comments when a student marks the complaint as unsatisfied. This ensures that every complaint has complete and trackable information on this blockchain. Complaint counter and mapping. Here, complaint counter keep the tracks of how many complaints have been raised. The mapping stores each complaint using its ID so we can easily retrieve it later. Events are like notifications for the front end. Whenever a complaint is raised, status is changed or reopened, those events are emitted. This helps the front end instantly reflect the updates in the dashboard.
Raise complaint function. This function allows a student to raise a new complaint. When it is called, increments the complaint counter, creates a new complaint and fills in all details, sets the initial status as pending, records the current timestamp, emits the complaint raised event. This ensures every complaint is recorded immutably on the blockchain. Change status function. This function updates the complaint status, for example, from pending to in progress or completed. In the front end, only admin users are allowed to do this. Even though the smart contract itself doesn't restrict it, the timestamp is also updated to record the latest action. Submit review function. After the admin marks a complaint as completed, the student can submit a review. If satisfied, nothing changes. If unsatisfied, the complaint is automatically reopened. Status set back to pending. The reopen counter is increased and the feedback is stored to the feedback array. Limit of 3 reopen attempts is enforced to prevent this misuse. This makes the complaint lifecycle interactive and fair. Fetch all complaint. This function retrieves all the complaints. It is useful for the admin dashboard where the warden or the hostel management can view every registered complaint in one place. Fetch feedback function. This allows viewing all the feedback messages for a specific complaint, especially useful for analyzing the repeated dissatisfaction or follow-ups. So overall, this smart contract automates and decentralizes the entire hostel grievance process by recording every complaint immutably on blockchain, allowing transparent status tracking, preventing unauthorized changes, supporting feedback and reopen mechanism, and this ensure trust, transparency, and accountability in this hostel management. So this is the smart contract part of my project. It handles all the core complaint operations, raising, tracking, resolving, and feedback completely on the blockchain for the full transparency and trust. The next following part will be explained by my teammate.
Hi, I'm Sahasra, and now I'm going to explain the backend part of our project. In backend, in the SRC folder, we are having controllers, models, routes, and server.js. Like now, I'm going to explain about the controllers. Like in this part of the project, we implemented the backend controllers and database models using Node.js, Express, and MongoDB with Mongoose. This section mainly handles three features: announcement, authentication through Google Auth and wallet linking, and Wi-Fi verification. Now, if we go to the announcement controller, in the announcement controller, we created a controller that allows admins to add, view, edit, and delete announcements. Add announcement, it takes a title and body from the request, validates them, and then saves a new announcement into MongoDB. If the fields are missing, we return a 400 bad request. On success, it returns a 201 response and the saved announcement. In view all announcements, this fetches all announcements from the database sorted by the latest first using created at -1. The API responds with a success flag and the list of announcements. And in edit announcement, we are having like this updates in existing announcement using find by ID and update. We return the updated announcement so the front end can refresh immediately. And in delete announcement, this deletes the record based on the ID. If the ID doesn't exist, we return a 404 response. Every function uses try catch, so if anything goes wrong, we return a 500 server error instead of crashing the backend. And now in authentication controller, this part handles login through Google Earth. When a user logs in with Google, we receive the Google profile. We first check if the user already exists in the database using their Google ID. If not, we create a new user and automatically assign a role. Like normal users are students and specific admin emails are like lower admin or higher admin. After that, we generate a JWT token that contains a user's ID and role and set it to expire in 1 hour. Instead of sending plain data, we create a safe user object that only contains name, email, role, and wallet address. Finally, we redirect the user back to the front end with the token and user info. So login becomes smooth and secure without manual passwords. And in wallet linking, and in wallet linking, there is also an endpoint for students to link their crypto wallet. The front end sends the wallet address and the JWT token. We verify the token, find the user, and update the wallet field. On success, we return the updated user. So students don't have to log in again as everything is handled through the tokens. And now the Wi-Fi controller, here, Wi-Fi credential verification is done. This controller checks whether a Wi-Fi name and password entered by a student matches what is stored. It first validates that email, Wi-Fi name, and Wi-Fi password are provided. It finds the record based on email and Wi-Fi name. If found, it compares the password with the stored one. If both match, then it's success. If not, it returns to the credentials do not match. This helps in verifying if a student is using the correct hostel Wi-Fi or not. And in coming to the database models, we have three database models. One is announcement, user, and Wi-Fi model. In announcement model, we have fields as title, body, and created it. It automatically stores the date for sorting. And in user model, we have Google ID, name, email, role, wallet, created it. Role can be student, lower admin, or higher admin. Wallet is stored only after the student links it. And in the Wi-Fi model, wallet is in Wi-Fi model we are having email, Wi-Fi name, Wi-Fi password, created it. Email is unique, so no student can have only one Wi-Fi entry. We also used mongoose.models.wi-fi to prevent model overwrite issues when the server restarts. And overall, we built backend APIs that manage announcement, handle Google Auth login with JWT role-based access, allow students to link wallets, and verify Wi-Fi credentials, all using Node.js, Express, and MongoDB. Now, Harshini will be continuing the next part. Thank you.
Hi, I'm Harshini and I'm going to talk about the SRC routes. So here, as we see, the first file, we are creating routes for announcements in our Express app. So at the top, we import Express and also a few functions from the announcement controller. Things like add announcement, edit announcement, delete announcement, and also view all announcements. Then we create a router using the express.router. So after that, we define different API endpoints, so which is post announcement add. So here it calls add announcement, which adds a new announcement, and the next is put announcement edit and also ID. So it calls edit announcement to update an announcement by its ID, and also get announcement from all. So this basically calls view all announcements to show all announcements. And finally, the delete. It calls deletes announcement to remove an announcement using the ID. And then finally, we export the router so it can be used in the main server file. So number 2, here it comes the auth routes. In the second file, we handle authentication, especially the Google login and the wallet linking. So we import Express passport and functions from the auth controller, Google callback, and also the link wallet. Then again we create a router. So next we define these routers as you can see. Get auth Google. So here it starts the Google login process using the passport, asking for the user's profile and also the email. And the next one is get auth Google and callback. So this route handles Google's response. So here comes the auth routes. So in the second file, we handle authentication, especially Google login and wallet linking. So we import Express passport functions and from the auth controller, Google callback, and the link wallet. So then again we create a router. So next we define these routers. So as you can see, get from auth and Google. So starts the Google login process using the passport, asking for the user's profile and also email. So get auth Google callback. So yeah, this route handles Google's response. If login succeeds, it runs Google callback. If not, it redirects to the home page. So next comes the post auth and link wallet. So runs link wallet, which connects a user's crypto wallet or other wallet in their account. So at the end we export the router just like the before. So in short, the announcement file manages CRUD, which is basically create, read, update and delete for the announcements, and the auth file manages logging in the Google and the linking wallets. So both we use express routers to keep the code organized and also modular. Now I'm going to talk about the main server called server.js, and it basically connects and runs the entire project, the backend, the database, authentication and even the front end. So at the top I import all the important modules: Express to create a web server, Mongoose to connect to MongoDB, Passport for Google login authentication, .env for environment variables, and path for handling file locations. So then I set up Express using app, which is Express, and enable it to the read JSON data. So since I'm using ES models, I also define underscore dir name properly, and then I serve my React front end build folder so that the both front end and the back end can run together. So after that I connect to the MongoDB using the URL from the .env file, and once it connects successfully, it prints Mongo connected. So next comes the session and the passport setup. So this helps store users login session securely. So then I configure the Google OAuth strategy, so users can log in through their Google account, and passport handles their profile information. So after that I add my routes, which is auth handles Google login and wallet linking. API announcement, this basically manages adding, editing, viewing and also deleting the announcements, and also API Wi-Fi checks. So this check the Wi-Fi login credentials, and also API contract ABI, which returns the blockchain contracts ABI and address. So there is also a fallback route, and since my React apps index.html for any unknown paths, ensuring front end routing works. So finally I start the server on the port and call a small function that adds a few sample Wi-Fi entities in the database. So overall the server.js is like a main hub. It connects the database authentication back into blockchain and also front end into one smooth running system.
I'll be explaining about the front end part of our project. So basically there are two main files in our front end part. One is the public folder and the other is the SRC folder. Now coming to the public folder, here we have two main files, that is like the hostel complaint system and the index.html file. Now so basically in this public folder, it holds all the static files that are needed for rendering the React application and connecting the blockchain. So the most important file is the hostel complaint system file, and this contains ABI and contract address, it allows the front end to interact with Ethereum smart contract. And now the file is automatically generated. This file is automatically generated after compiling the smart contract. It contains the ABI, that is the application binary interface, and list of functions and events. And it also has the deployed contract address, and it also has our network information. So basically, it has like four functions. One is the raise complaint function, and the other is the change status function, and the third one is the get all complaints function, and the final one is the submit review function. So without this file, the front end cannot communicate with the smart contract properly. Now coming to the index.html, it is a root HTML page where the React is mounted. So in this file, it is the main template of the React file. And when the project runs, the React is injected into uh, this specific line div id root, and so here it loads the bootstrap css and app icons, and it also manifests the pwa of our project. And even though the React uses components, the browser still needs one base HTML file. So all the pages load inside this single HTML React router. So this is like a single page application of a project. Now coming to the second folder, that is src folder. Inside src folder, we have index.js, index.js, app.js, and api.js. So index.js starts the React application and activates the authentication for all pages. And app.js is the main router that controls navigation, user roles, and MetaMask connection. And we have api.js. This file creates an AJS instance to communicate with the backend server. Together, they handle the login, routing, and protected access for students as well as admins. And they also help in blockchain in wallet integration. Now, we'll observe the index.js file. This file is first executed in the first front end. So it renders the app and inside the index.html using like we have seen the divide id is equals to root, and this renders the app here, and it wraps the entire app inside the auth provider, which manages the login state. So this is basically the Google authentication here. This starts the React UI, and it makes the authentication available to all the pages. Now coming to the app.js. This is like the main page routing plus a MetaMask connection file. It is a central controller for the front end, and it has all the home features, student panel, uh, and lower admin, higher admin panel. And we also have Wi-Fi login here, and it also has admin announcement panel here, so that the higher admin can add any announcement or they can edit any announcement in this function. So it is basically a role-based authentication here, and only this ensures that only the students can access student pages and only the admins can access the admin pages. It basically controls the access, and it also has MetaMask wallet connection here. Uh, it also allows all the blockchain transactions. It saves the wallet addresses in a local storage, and it also detects account change. And without MetaMask, this file cannot be run. Now coming to the api.js file, here the Axios is set up for the backend communication. So this file creates a single Axios instance, and it is used by all the components to call backend APIs like MongoDB or Node backend. And it also checks the Wi-Fi credentials entered by the students. It fetches the complaint list, and it also checks the admin resolve complaints, and it also verifies all the announcement given by the higher admin. It keeps all the HTTP requests consistent and easy to maintain. So, in conclusion, our hostel resident grievance management system improves transparency, security, and accountability in handling complaints. So, by storing the grievance records on immutable decentralized ledger, it prevents data tampering and any sorts of delays. It also builds a sense of trust between the students and the authorities and makes the resolution process much faster and more reliable. So, with future scalability and real time grievance tracking, it can be expanded to other institutions as well. Thank you.